The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, wherever you are in the world. I'm Scott Hayes, a lifetime IBM champion and IBM DB2 Gold consultant, and the host of your show today. This is the DataView Show, episode number 17. We're going to be talking about DB2 best developer features. Our special guest is none other than the amazing and talented Mr. Tony Andrews. Tony, how are you today?
I'm doing great. Thank you.
That's good to hear that you're doing great. It's better than alternatives that are going around these days. So I'm really happy that things are going good for you. We've got Tony's contact information here for you on the title slide. On Twitter, he's at Tony Andrews 12. What is the 12 for, Tony?
It was the next one after 11 available.
I
How
see.
about that?
All right, so there's 11 predecessors. All right, let's get number 12. You can chat Tony up, follow him on Twitter, and his LinkedIn is there as well. Tony A. Andrews is your middle initial A?
It is.
All right, well, now we've got all the secrets on Tony out, except we need just one more. Tell us something personal about yourself, a hobby and interest, a non-DB2 thing.
On DB2, well, let me think here. A few years ago, I started picking up the ukulele. Had purchased it for one of my daughters. She was interested in it, and then never really ended up doing much with it. So this one day I picked it up and go, hey, this is kind of fun. And a few years later, belonged to a couple of ukulele groups and done some stage presentations, and that's kind of a unique thing that I have a lot of fun with.
Well, that is pretty cool. So you're musically talented as well. That's great. All right, let's giddy up and move along here. This is the Required Gibberish. Thank you, IBM. The opinions expressed are that of Scott Hayes and the show guests, and do not necessarily reflect that of IBM Corporation or the IBM community. DB2 is a registered trademark of IBM, which is also a registered trademark. We make no claims to any marks belonging to anyone. They're yours. You can enjoy them. This event is being recorded and replays will be publicly available. So we ask everybody to mind your manners. If you have any questions during today's show, use the GoToWebinar question and answer tool there, and we'll work on getting your questions over to Tony. Sometimes we do the questions in the while he's presenting, and sometimes we hold them to the end. What's ahead? We're going to get Tony on with his presentation, Best Developer Features. Specifically, his presentation is designed for ZOS versions 9 through version 12, and he tells me there's a great deal of applicability to DB2 LUW as well, because, it's the DB2 family and SQL is SQL. So there we go. And we'll have some news bits for you. We'll have a couple polling questions, and then we'll do thank yous like we always do. So, best developer features. Tony, we're going to make you the presenter.
Okay.
Click that button and we'll see your beautiful screen.
Show my screen. Should be able to see it.
Oh, it looks so fantastic. It's the best looking screen I've ever seen.
Worked hours on it.
It's beautiful, man. You even got like a Twitter button there.
All right. Take it away.
Take it away. You're on the air. It's your show, man. I'm just here to run the buttons.
All right. Thank you very much, Scott. inviting me and having me be a part of this. Many of you out there may know who I am. I get around doing consulting. I get around doing training. I'm an IBM champion. I speak at the IDUG North America and IDUG EMEA conferences every year for quite a number of years. Do some workshops there. Help support a lot of the user groups. I get around. And for those that may not know me, I come from the developer background, and I grew up as a developer. I'm still a developer. I've always liked being a developer. I have been a application DBA on some projects, but I really like the development side, and been out doing a lot of consulting and contract work, helping people put applications together, doing a lot of performance and tuning consulting to help get applications to run better, a bunch of batch jobs to run better, online transactions in a certain application to respond faster. And I just always liked that side of IT.
Well, you sound like a very busy, talented man.
Yeah. With that said, I've noticed over the years a lack of knowledge and skills from the application side, and that's what kind of drives me a lot in what I consult in, and what I do a lot of speaking engagements on, is to get developers empowered, okay, and get them empowered to get stronger in some areas, and know some of the areas a little bit better. And I also noticed lately, some of the places I've been to, and I say lately, I'm going to the last year or two, there's a lot of great features out there that are not being fully utilized. A lot of developers not know about. So this is what this presentation is all about. There's a few things about questions. There's a chat window. Try to hit some of them. We don't hit them all. We have ones afterwards. Send me an email, tandrews@themusinc.com. Okay. So I want to touch on some of my favorites. There's been a lot of stuff going back even to version 8. As it went from version 8 to 9 to 10 to 11 to version 12 now on the ZOS platform. There's been a lot of things for developers. And I'm going to show you some slides coming up here on many of the things that have come out. And we've actually, at Themis, we've actually incorporated like mostly 2-day classes on just application features on these new versions that have come out. So to me, being a developer, this is really exciting for me. Like, wow, we got a lot of new SQL, we got a lot of new functions, we got a lot of new things we can put in application design. We have a lot of new optimization things that can get stuff to even run faster, just on and on and on. So I'm going to hit on some of the what I have found most useful, and the ones that always had caught my eye initially, and incorporated in some standards and guidelines and in some application design. And as always in presentations that I do, I like to have some great examples. I like to have some good takeaways. I know we can all probably agree that we can never have enough examples of things that we're working on. I want code. I want to see some examples. I don't want just a description. I want to see some examples. So you'll have some to take away today for sure. So I'm not going to go through each one of these right now. I'm hitting on what I think are some of the more common and more popular ones as we're going to go forward here in the presentation. I just want to show you. Here's things that came out in DB2 version 8. This is all specifically for developers, okay? And I'm going to go to the next page. And here's a lot of things that came out in version 9. Version 9 was really big. Got a couple of pages here of stuff on version 9, all specific to developer stuff, okay? Then we go to version 10, and there's a lot of things at version 10. Specifically for developers, that we can use and incorporate in our code, in our applications, in our programs, in our designs. Version 11 had more stuff. Okay, we go to the next one. Version 12 had more stuff. So as you see, there's a lot here. There's probably 50, 60 things here, and I don't think I even have all of them listed. So how many of these, the developers that are out there coding day in and day out, and week in and week out, how many of these do they really know about? Or maybe they know about it, but they don't know how to implement it. They don't know how to code it, whatever it is. There's a lot, okay? So I'm just going to kind of sum up. I'm going to start off with the merge statement. It's been around for quite a while. The merge statement is an SQL statement that allows us developers to send a statement to DB2. And I'm going to send along with that some values, one of which is a key value that is going to be read by DB2 on a table. And if that row is there, it's going to go do an update based on my update logic. If the row is not there, it's going to do an insert based on what I'm feeding it in my statement for column values. So why is this kind of important or kind of cool? Well, you know, from a developer side standpoint, you know, I think we have two things to do as developers. We got to get our data correct for sure. You know, whatever we're presenting it, whatever we're doing, it's got to be correct. Number two, we got to get it back as fast as we can. Okay, we want response time all the time, as fast as we can get things back. Well, one of the things that slows down programs is too much what we call conversation between their program and DB2. So we're in a program, no matter what the programming language is, we send an SQL statement to DB2, it leaves our programming environment and runs in the DB2 environment. Okay, for the ZOS people here, that would be the DBM1 address space. Okay. That sending of an SQL statement has some overhead to it. So if I have a program that's going to be running and doing, you know, many SQL statements, if I can minimize the amount of times I send a statement to DB2, I can pretty much guarantee you that that unit of work or that whole process is going to run faster. So a term that I always often like to use, I like to tell developers to think more relationally, not procedurally. Don't go step by step by step by step by step and execute all these hundreds and thousands of singleton SQL statements and break up your joins and all that. So what DB2, what IBM DB2 has done is they came out with some other SQL statements that helped us go over to DB2 in one statement and have multiple things happen. Okay, thus this is what the merge statement is doing. Okay. In version 12, they have some great enhancements on this merge statement. Okay, not only can I just like update or delete based on a key value, I can update based on some other logic in there. And here's an example here. You know, allows for select to specify input. They allows for multiple conditions on a when. Allows for a delete option, or I could just ignore based on a certain condition. So we have a lot more things we can do in version 12 on this merge statement. On the next screen here, it also allows us the source data to be different than what I'm going to be updating. I can query from one table and use some of those key values to read another table, and then go do my updates, my inserts, or my deletes, or my ignores, whatever I want to do. So we have a lot of logic that's built into this one statement, and this is a great thing because we can send it to DB2. We have all this stuff like checked over there. Some action is going to take place and then it's going to come back. I don't have to go and check and then come back in my code and decide based on what the SQL code was, what I want to do next. I can do it. I can build it all in one query.
It's like making one trip to the grocery store instead of 20 trips to the grocery store. Awesome. That's
a great analogy. Another couple ones along that same line is we can we can code up some queries with these keywords old table and final table. And here's an example here of using the keywords final table. Okay, so oftentimes this comes in real handy for tables that are designed where we as developers do not provide the primary key. DB2 is going to assign a next available incrementing number to assign to that. Like order numbers. I don't want to give it an order number, just assign the next order number, okay? But when I do an insert, I often need that key value. I want to show it on a screen, I want to show it on a report, I want to do something with that key value. Go down and insert into a child table. So what would we tend to do? We'd have to do a couple trips to go back and get that key value. Well, if you do a select from final table, okay, and I do my insert, it's going to bring me back whatever I have in my select after that action takes place. So after this insert takes place, it's going to bring me back what I'm asking for. In this case, I'm asking for a customer number, which is going to be the next value that was assigned by DB2 as the primary key. So for you developers, that'd be a select into followed by an insert statement. And thus we have the insert and I got my key value all in one statement. Works the same for sequencing. It works the same for these old identity columns, you know, that have been around in DB2 for a long time. We can do the same thing when when we have an identity column defined. It was the old-fashioned way of DB2 assigning a key value for us. We could do the same thing there. We insert into it, and like up the top, I would tend to have to go back with, you know, to go get that value. I can do the same thing there, whether it's a sequence number, it's one of those identity key values. Okay. Final table says, give me this information after this action takes place. Now, could I do a select from a final table after I do a delete? No, that's not going to work because there's nothing to bring back after a delete. Okay, but you could do some things that we're going to see in a couple of minutes. There's another key phrase called old table that says, give me this value before I do an action. Okay, delete's a perfect example of that one.
Hey, Tony.
Yes.
There's a question from Donald. He wants to know, does the insert need to be committed, or is it the final table in memory at that point in time?
Does it have to be committed? No, it does not. No, it does not. You're gonna get that value back, and if you hit some append or you actually executed the rollback yourself, obviously those are lost. Those key values are lost. That's why you see sometimes some gaps between some of these automatic incrementing numbers and the primary key value.
Thank you.
Hope that hits your answer there.
Donald says thanks.
Okay, great. Let me try to get myself to move forward here in my PowerPoint. Seems to be frozen for some reason.
It's that little.
Okay.
That worked.
So what the interesting thing that came out with the merge, if anybody's worked with that, is, you know, your merge may come back and you get an SQL code of 0. And you're like, okay, great, it worked. All right, yeah, but what did it do? Did it do my insert? Did it do my update? I mean, what did it do here? So we have to do this kind of logic. We have to kind of add a column on the fly, and then I update that column in one of my actions, and we're selecting from final table. This is where this keyword final table comes in. I want this information back after this action takes place, but I have to go include a column. It can be called whatever you want. This, in my example, is update indicator, UPT_IND. I need to select that back into your program, yep, along with this merge, and you'll get your I or your U or your D or whatever you're going to be doing in your merge statement. Okay. The other one here is the old table, keywords in SQL, and we're going to select something before the action takes place. Okay. Delete is a great example of that. So before it does a delete, let me know what you're going to delete. I mean, this is kind of a good thing for testing. It's a good thing. It's a good thing in your programming that maybe you want to keep a list of things that were deleted. There's nothing worse than doing a delete, you know, on the fly, and you see 14,682 records deleted, and you go, oh my gosh, what happened? What was my logic? What all was deleted? Great for testing. Great to put into your code. You can set this up. You would set this up as a cursor, and it would do the delete. You could fetch through all those rows that were deleted, whatever values you want, and do whatever you want to do with those values at that time. You know, go write them off into an audit table or something. Okay. So we have multiple things happening at one time. We got the delete and the bringing back of the data that was deleted to us, whatever columns that I want. You know, in SQL programming, this to me is a really awesome thing. It just, anymore in SQL, you can put a select statement. You can put a select statement in the from, which we've always been able to do, called a table expression. You can put a select statement in the select. You can put a select statement in the where. You can put the select statement in the with. You can put a select statement in the having. You can put select statements like anywhere anymore. And along with that, now, or for the few versions now, we can do an order by and a fetch first in any of those. Now, we used to not be able to do that. You know, we could have a select statement, but I couldn't have the order by and a fetch first in there, in places within our SQL statement. So now we're pretty much free to put this just about anywhere in SQL, and this is great to handle. So it gives us other ways to handle some logic that we're trying to drive out of our queries. There's an intersect and an except that we're going to take a look at that's kind of unique. The queries are coded up just like a union all. So if in my first select I have 2 or 3 columns, my second select I have to have 2 or 3 columns, and they have to match by data type. You know, they don't have to be the same column names. Could be coming from a couple of different tables. But here's an example here. You know, if I have a query 1 and I do an intersect into query 2, the syntax is going to look just like a union or a union all. And let's say this is what we get. We just have 1 column coming out. If I do an intersect, the intersect's going to say, okay, in one query I have some Abbotts, Jones, and Smiths. In the other query I have some Bakers, Jones, and Smiths. But what's the intersection there? Well, the intersection is they both have some Joneses and they both have some Smiths. The intersect all is going to tell them how many Joneses they have in common and how many Smiths they have in common from the outputs. Great for a many-to-many relationship between tables. You know, how many key values do I have here and also over there? You know, if it happens to be some key value, you know, where it's a non-unique key, for example. So this is a way to do it. It's also a way to find out something in one table that's also in another table. I mean, how do I find something in one table that's in another table? Well, we could do exist logic, we could do in logic, we could do join logic, we can do intersect logic. We have 4 different ways to see if a key value in one table is over in another table. Very common logic that we developers code all the time. This gives us our 4th way to do that. Now, what most people typically ask me is like, well, which way's best? Well, there's not always one way that's better than the other way. There's too many of that it depends comes into play. So we as developers need to know all these ways and try all these ways. So when we go to production, we're going with the way that had the least CPU, the fastest response time. So intersect can be used for that also. And it can also be used for that many-to-many doing the intersect all. On the next page, the same thing with the except. Okay. Now with the intersect and the union, it doesn't really matter the order of which you code your queries. With the except, it does matter the order of which you code your queries. So we're looking for exceptions. Exceptions out of the first query being compared to what's coming out of the second query. And the same thing, we have an except and we have an except all. So first query, got some Abbotts, Jones, and Smiths. Second query, Bakers, Jones, and Smiths. So what's the exception? Well, we have some Abbotts in the first one that we don't have in the other one. If I physically coded those up, you know, the opposite way, then Baker would come out. We have some Bakers in the first one that's not in the second one. Want to do an except all, okay? If I had 10,000 Abbotts, the way this is coded right here, if I had 10,000 Abbotts, the except all is going to show all 10,000 rows coming out. All of those, every single one of those are going to be an exception to the other one. So this kind of goes back to the same thing here. What key values do I have in a table that's not in another table? Well, we could do not exist. We could do not in. We could do what's called an anti-join, okay? And we can do an except. So now we have 4 ways to figure out something in a table that's not in another table. Another very common way that we code in application logic. And again, which way is best? Well, you know what? It depends. Sometimes one's going to outperform the other. Sometimes the other's going to outperform the one. It has to do with the amount of rows coming back, the clustering order of the data, the indexes that are on the table. There's a lot of it depends comes into play there. Okay. Version 9 came out with these ranking functions. Pretty nice, simple. I thought these things were just great. I know I had been on projects in the past where this would have really come in handy. It had been on some things like since where this comes into play. So there's these ranking functions. And many of you have probably seen these pretty simple examples here, you know, rank over some, in this case, salary descending. Here's a case where we have a tie. This Heminger and Lucchesi both make the same second highest salary, so they both get ranked number 2. What does that make Thompson? Number 3, number 4. What if there's 100 of them that made 46,500? What's that make Thompson? You know, well, it depends if you code the rank here. If I go to the next page, we do the dense rank. The dense rank, it doesn't matter how many ties. Thompson is going to be the 3rd highest salary. Now, if you want to break the ties in your order by, in your over logic there, in your order by, you can say order by salary descending, comma, bonus descending. Go another do another column to kind of break a tie if you want. So you can add more things in your order by. So the syntax is pretty simple, yet it's pretty powerful here. You know, this is a great way to give me like top 10 of something. Give me the people that make the top 10 salaries versus, you know, so what if I have a whole bunch of people that have the same second highest salary? The top 10 is going to be more than 10 people. How do we do that? I can't just say order by descending, fetch first 10 rows only. Because what if there's 50 people that make 52,750? Well, you're only going to get the first 10. You're not even going to see the other 9, you know, top salaries. So this is one way of a number of ways to kind of hit that logic by doing let's rank them, you know, in a common table expression, and then let's go after our common table expression and give it the ones that have a ranking 1 through 10. Okay. Row numbering, they all get unique numbers. Sometimes we do row numberings, you know, to output some files that people FTP up into their spreadsheets or whatever the reason is. I've had to output files before that we sent over to some other company, and for some reason they wanted every record in the file to have a record number. Okay, so let DB2 do it instead of me trying to programmatically do it in my code. Okay? Whatever the reason is. Okay, so even though there's ties, everybody's going to get a unique number. Okay. Now, here's an example coming up here of there's a number of different ways that these rankings can really kind of come in and help out in something that we're trying to get to, like percentiles. Okay, top 5, top 10 that make the highest salary. What if I want the top 5% or the bottom 10%? Wow, how do I get that? Now that's a whole different going to be a different output than just my top 5. What's my top 5%? Well, in order to do that, you need to know a little bit about percentiles. You know, you have to know the total number in your data, and you have to know like a ranking. So, for example, if there's 600 students in a class, and you're 20 divided by 600 times 100 equals 20, 100 minus 20 equals 80. You're in the 80th percentile, which really means you're in the top 20%. I always found this confusing. You know, especially when kids come out of school testing, say, and the first thing you see on page 1, like, oh, they're in the 90th percentile, and you go, 90th percentile, wow, they're way down. Well, no, really, what they're saying is you're in the top 10%. Okay, so we can use rankings to do this kind of stuff. So here's a query here that does some dense ranking here. Okay, and then you can see this is a ZOS SQL thing where we use a small integer function, you know, so I don't get a bunch of decimal points out and such. Okay, and we're taking the number 33. We have to know the number. We have to know the number. Okay, and I could put a select count in there because, like I said, we can put select just about anywhere in SQL anymore. But here's a logic that would get this, and I say, well, the percentile is greater than 95%, greater than or equal to. That's going to get me the top 5%. So we're using the rank functions to help us get the Okay, it looks like my audio connection may have been lost. Scott, can you hear me?
Well, it did cut out there for a moment. Maybe this is,
okay.
Do you have like a phone you could dial in on?
Have I been going in and out? here?
It's only happened a couple times. We can let it go. I was just
Okay.
thinking it's the bottom of the hour and it's time to take our little break. And if you wanted to switch up your
Okay.
audio, you could. Go ahead and finish
I
this
don't think.
slide, and then I'll do the break.
Okay. Yeah, so here's just an example of running this query against a small set of the employee sample table that all DB2 shops have. We happen to have a couple of HOSs, you know, in our data. We kind of added another one in there just to help drive home some of the workshops that we do in our SQL classes. But there's two people that really make up the top 5%. That's the idea there on all the rankings. Okay. So the point being there is we can use the ranking functions to help drive some other kind of analytics sometimes. Okay. And in version 12, I don't really go into this or have examples on this, but there's a couple other percentile functions that we can do now. You know, used to answer questions like what salary is a 95th percentile for a specific department or for a specific job. Just some other kind of things. Now with these functions, we don't need to use any of the ranking functions, but they calculate something a little bit different. But along the line of percentiles, I just thought I'd throw this slide in there. Don't really have an example of it, but some other cool things. SQL is becoming pretty powerful with SQL analytical stuff now that we can do. Okay, I'll let Scott take over here for a minute, and then I'll come back to our material.
All right, thank you very much, Tony. All right, I have some good news for everybody. It's a very common question people usually ask, can we get a PDF handout? And the answer is yes, we will make a handout available during the last 5 or 10 minutes of today's show. It'll be in the little handouts tool there in your GoToWebinar viewer. And we'll also make the PDF available from the replay blog. The replay blogs are found at dataviewshow.com/news. I usually have those up within a few hours. And remember, if you have any questions for Tony like Donald did, you can just pitch them over and we'll get to them, or we'll hold them if we get overwhelmed with questions. Some upcoming shows you should know about. On the 21st of May, we've got a really cool guest from Ireland. He's going to be talking about cybersecurity and QRadar and some other cool IBM technologies. On the 4th of June, we've got a presentation on IBM replication, data delivery in 2020. That's with IBM Gold consultant Frank Fillmore. He'll be the guest. And on the 18th of June, a topic that I think is pretty cool, Internet of Things, the Tririga platform and workflows. Would you like more DataView shows? Well, IBM community was very kind to fund the DataView show and make these shows possible. And IBM is currently deliberating if they want to renew the show, right? They're trying to get budget to do this again next year. So if you'd like free education to keep coming at you via the DataView show, I ask that you might email our dear friend, Stuart Littell at IBM, and tell him that you love the DataView show. Tell him that you learn a lot. Tell him that your knowledge from these shows helps you keep IBM technology within your organizations, because it is community knowledge and education that furthers our careers and our organizations. Stuart Littell can be reached at SLITEL@IBM.com. I'll put that in the chat too. Help me out with that. So, Stuart needs to know that a lot of people love the show. Some URLs that are worthy of your attention. If you're not a member of the IBM community yet, you want to check that out and join. There's lots of discussions and information there. I'm going to have more on User Group Day, which is next week. I have a slide coming up on that. I want you to know that yours truly is presenting on May 19th at 1 p.m. Central, 2 p.m. Eastern. topic for me will be the State of the DB2 Universe 2020, and that is a very interesting presentation. We surveyed the worldwide DB2 community, and we found out who's using DB2, how they're using DB2, what the most popular tools and features of DB2 are, and all this information will help you understand or make sure that your skills are in alignment with those things that are most popular. And there's some surprising movement and shift in the tools area. I thought that was very interesting. That's my teaser. IBM.biz/DB2 console, you can get a hold of the successor product to IBM DSM there. IIUG.org, that's the Informix user group. IDUG.org. Yeah, IDUG is still alive. The Dallas conference has been postponed. It's probably going to go virtual. Stay tuned from IDUG on that. And if you haven't checked it out yet, www.ibm.com/cloud Watson Studio Auto AI. Cool little tool there. You just upload data and Watson tells you stuff about your data that you didn't even know. It's really cool. Here's that more information I promised on the virtual user group day, May 19th and 20th. There's more information at community.ibm.com. And you register at ibm.biz user group day. It's a virtual community event. It's totally free. They're going to have some keynotes by senior vice presidents, 6 tracks per day, 96 hours of content by 140 speakers. There's over 14 user groups participating. Sessions will be live and they'll be recorded for later replay for just 90 days. May 19th and 20th, there's some more details. Let's see, DB2, 8 hours. There's a track on DB2 on that. Oh, and there's something new called IBM Tech TV. So check that out too. All right, what else do I have for you? Ask the audience a polling question. I can do that. Select a poll. Just to make sure our good-looking audience is awake, Tony, I'm going to ask them how they heard about the show today. We do a little bit of Twitter stuff. We did a little bit of promotion on LinkedIn. We've got a newsletter. We've got our homepage that people like to visit. And we're also very involved in the IBM community. We put our events in the IBM community. Well, Donald chimed in with a question, said he got the newsletter. All right, thank you for that. Oh, okay, and Bill says that IDUG has announced their virtual conference in July. Email was received about an hour ago. Thanks for that insight, Bill. Some people say they can't select an answer. I don't know if it's the device that you've connected to on or not. It's on the desktop, which I'm using, you just click one of those buttons. All right, I'm going to close the poll and share the results with everybody. 9% Twitter, 47% our newsletter, 9% the homepage, and 35% from the IBM community. Yeah, I've noticed that especially DB2 mainframe folks, they really like their newsletters. That's a very important way to get the word out about what we're doing. So we'll keep doing those newsletters. And a few people found us on the show homepage. Those would be our groupies, the people that visit regularly. And a few people from Twitter. Okay, very good. Let me see what's next here. I think it's time to put Tony back on. Tony, are you ready?
I'm ready.
All right, man. Click that button. We'll see your good-looking screen.
Okay, here we go. Row change timestamp. This is an awesome application design. There's nothing more frustrating than being in a meeting and people trying to figure out how some data got changed and everybody saying, I didn't do it, I didn't do it, I don't know what happened there. let's at least get a timestamp on when, a row had changed. Let that happen automatically by DB2 by adding this on the table. It's a great thing. At least at this point, we know when some rows were modified, okay, or inserted, either one. Okay. Let's go to the next page here. Okay, you can use that row change timestamp column, for logic, like we see here. Along with that, there's a RID function that's been around for a while. I have another one of these. I've used this like numerous times in some batch processes, where we're going through a lot of data, and it's like a cursor. And some of those rows we are then going to go and update. Some of them we don't go and update. We do something else with it. So when you go and then do an update, oftentimes, people in their code, they go over and do an update, and in their where logic, they're putting the primary key and it's going back to the index and finding where that row lives in the data file and doing the update. Well, the RID is a function that actually internally comes back with a number, but the DB2, it is the page and the offset that row lives in the data file. So if I'm already selecting data, and sometimes I'm going to go back and either delete or update that row, let's use the RID function. Let's take that RID value, it's called direct row access. That is much faster than having DB2 go back to the index to refine the row that you're sending a update or delete from, okay? People say, okay, well, that's great, but rows can move, right? What if the time that you fetch it and the time you go and you update it, you have this RID function, maybe the row moved. Well, what would make a row move? Well, if they're doing online reorgs, can put things back in order, move. People are updating variable character data. It makes it like too big to fit on the page, not enough room, moves it to another page. There's some situations where that could occur, and they have to find its place right in there between, we're selecting and going back and updating. So this is where we can use this update timestamp. Optimistic locking is called. So when we fetch our data, let's bring the updated timestamp that's there on that row. And when I go back to update it with my RID function, let's make sure that update timestamp is what I had it when I fetched it. Because if it's different, that means somebody somewhere updated that row and DB2 automatically updated that timestamp. So if they're out of sync there, then I know, oh, somebody jumped here in the middle and that row was moved. So I probably need to go back and refetch the row. Okay. So it's called optimistic locking. This is a good way to get around that particular problem. In version 12, we can also now get the user ID from a session user. Okay. Keyword in DB2. So now we can, by putting this in place, somebody does some inserts and some updates, we can get when it was done and who did it. This is invaluable information. I've been in a lot of meetings where everybody's saying, no, I didn't do it, I don't know what happened, everybody's putting the blame on everybody else. This kind of helps us figure out maybe what the problem was, okay? Got to be Apple Compat version 12, release 1 M504 for that user ID. Okay, moving sum and average. This is great when we're getting a little bit more into analytics and looking at some trends, or we just want to get an aggregate value out with our detail value on each row, okay? There's a lot of ways to actually do that. Like in this case, our detail data is EMPNO, department number, salary. Our aggregate data is the sum. So now we're looking at people's individual salaries and comparing it to maybe an average salary or the sum of salaries, or maybe it's a moving sum like we see here. So the moving sum is just going to keep incrementing and adding on each of these salaries and coming up with the total for that up to that point in that line. So when you get down to the very last line of your output, it's going to be a sum of all the salaries that were previous, okay? And you can do the same thing with average, okay? Next page. You can do a partition by. We can start this over on whatever we're partitioning by, in this example, by department number. So we're going to start going through the lowest to the highest, summing salaries, and then on the break of department number, we start all over again. So the last row of our output for each of the department number values, that's the total amount that's paid out by that department. Okay. And again, we could do averages. We could do like here's a case. Here's an average. Okay. This row's unbounded. There's some different things that we can do there. Sometimes we may just want to do a moving 2 or 3 row average. So you take the current row and the previous 2 rows to get an average just based on 3. So as you move along in your output, it's a 3 row average. Okay. And sometimes developers go, well, why would they ever want to do that? And who would ever want to do that? Well, I know by working in some retail and some fast food industries and done some big projects, the salespeople and the higher ups and the CIOs, they cannot slice and dice data enough, and they just want it all kinds of different ways. We now have more power to present all these different ways to get the data, and they like to see that. Then we're talking trending. We can see some things here, like in the next page here. We're going to see that average salary actually trended down as time went on for designers. Okay, kind of interesting. So you can use this stuff for like some analytics and some trending information. Okay. All right. Next thing I found, a lot of people found very useful, the timestamp precision. The timestamp goes to hours, minutes, seconds, down to the 6 microseconds. We can now define those up to 12 microseconds. Okay, this is real key for those tables where timestamp is part of the primary key. Data inserts can go so fast anymore. Having a timestamp down to 6 microseconds is not fast enough before you're going to get a duplicate insert at times. So we can increase up to like 6 microseconds for timestamps. Comes in very handy in application design for those times, especially when that happens to be part of the primary key. Current timestamps, we have some different current timestamp special registers here. I could get timestamp with time zone, depending on what your machine time is. Get some information out there. That's all good stuff. Currently committed. This is something I found very helpful on a project that I was doing where there's little batch jobs that kicked off and on during the day. Like there'd be so many these, what they call these adjudicators. We're doing adjudicating all this information, and they would set these records aside to then, and then every like 30 minutes a job would come along and fire these up and go do some inserts and some updates and some different things, So the front end applications, sometimes they would be put into a wait state as they're going to query something because they're getting locked out. And their response time at times during the day would be like much slower. They didn't get ever totally locked out, but they may get locked out for 10, 15, seconds, and then all of a sudden their screen would show up. And as we analyzed it, it's like, yeah, you're going into a lock wait state. And a lot of it has to do with these little batch jobs that kick off and on. So we would take those packages and we would bind them with this bind option here. So when they would go do a read on some data, if there was a lock on the data that happened to be due to a delete, the reader would still get the row. If the lock was because of an insert, they would not get that row. So that data had not been committed yet. That's what the data looked like at the time I went to read it. Okay, so they don't get any lock wait time. They just get what's stated there in red. Okay, somebody else did a delete, but they haven't committed that delete yet. I go and do a read. I'm not going to get locked out with this. I'm going to pull the data that meets the criterion. If that's the row that some other application has deleted but not yet committed, at that point in time, that's what the data look like. Okay. Now, what happens on an update? On an update, you're going to go through the whole lockout. You're going to be put into a wait state by Db2. They're going to wait 30, 45, 60 seconds, whatever your DBAs have set for that. If that lock hasn't been released, you're going to get a minus 911 back. If the lock gets released, you're going to get to your data. Okay. I found that very helpful at times when you're having some locking problems, we need to figure out what is locking it and what is the lock. Is it an update, an insert, a delete? What caused that exclusive lock? Okay, from the other end. Okay, a few pages here on XML. I know a lot of people don't do much with XML. I've been on some projects they do a lot with XML. For a while, they stored XML documents as character large objects. Version 10 says, no, you can store those as an actual XML data type. It's its own data type. And it gave us this whole great XML, query language to go in and pull data from it and index items within. Became like all so powerful. And it's just, it was just great stuff. And so here's an example of an XML document, and very similar to what JSON data that we're going to take a look at here, in a minute. Okay. So, XML has been around for a number of different reasons. It's been around for like a long time. Okay. So we can use this XML query function to pull pieces of information out of a document. Now let me back up here. I only want to pull out like a service date and the reason, for a specific service date across, all these documents. So it's actually going into the document and pulling out a piece of information. So you kind of have to know how your documents, laid out. So there's some examples there of some things that we're pulling out. You can use XML exist logic. I want all the rows of data that within their document, they have something that exists in there, some certain values. And we can create indexes to speed up looking through those XML documents for a certain part of the document that has a value. This is all, anybody that has anything to do with XML documents, on their in their application, this is just outstanding. Because what did we have to do before? We would have to bring the whole document into our program code and then string through each of the documents looking for something. That's a lot of processing time, okay? Temporal tables. I thought this was just outstanding too. Same idea is like when a change happens, we saw before, we can know when the change took place and who did the change. What the temporal tables do, especially, I'm just going to talk about the system type, because this to me is the most popular and where I found the most in applications, this is the perfect fit. We create a table, we add some of these key columns there at the bottom, these not null generated as, okay. We create a table, like a history table, okay. We do an alter statement from a DBA point to tie those two tables together. So now when I do changes to something in the main table, a row automatically gets moved over into the history table. So I'm constantly keeping track of my changes. This is an incredible application design for me, okay, and for a lot of people. And in fact, I think any table that gets updated like often, columns get updated often, this should be a part of their application design automatically. And by having this application design, we can go back to a point in time. Well, what was somebody's salary like 5 years ago in June? We can go back and we can figure that out with real simple queries, okay? If I just writing things out to a history table, sometimes that can be kind of cumbersome to try to figure that stuff out. So with this comes along some like really good SQL syntax. Give me some information for system time as of. System underscore time is a key word in SQL, or between. And it's going to go back and find that point in time and show you what the data was at that point in time. That is great for figuring out problems that are going on in maybe a production or a test environment, for testing purposes, for just a lot of querying capabilities. We always wonder, like, gosh, how many people did we have under this certain condition, last year at this time? I mean, all kinds of questions come up where this can like really fit perfectly into finding those things out. Query number. We can add query number into our queries. This to me, a lot of this to me is like, this should just be a standard anymore. The query number is used when you do explains. The DB2 will use those query numbers when it inserts data into the explain tables, okay? That becomes invaluable as opposed to it picking its own query numbers. And every time I pull programs out and move them back up into production, there's new query numbers that are getting generated. So it's hard to see a history, or it's hard to see a trend or some changes that have taken place. But if I look at my explain output and I see query number, I know exactly what query in my code it's referring to. And I can look at query number over last 4 or 5 times I moved into production and look to see if anything happened to have changed. For DBAs that get involved when they're doing some override to the optimizer, this query number comes in really handy for that. okay? And you just add it to the end of your query, okay? Global variables came out in version 11. Just real quick on this, got a number of topics here to get through in the next 10 or 15 minutes. We can create a variable, okay, give it a name. I could then load up that variable, and my whole logical unit of work can share that variable and the value that's in it. I call a store procedure, it can use that variable. Or maybe the store procedure loaded that variable, I can use it back in the calling programs, okay? This is really good, you know, like this, you set the global variable in one of your programs, all the other programs, you know, that's part of that unit of work can now get to that value and can use it. This is great, especially for stored procedures. If I need to pass it something else, if typically what I have to do is add another parameter to the stored procedure. Well, that means dropping the stored procedure and then adding the parameter, okay, putting the stored procedure back out there, invalidated all the packages that call that stored procedure. You know, it's kind of a mess. Well, let's just create a global variable and let's just change some source code real quick, move it back up through production, and that's another way I can get a value into a stored procedure, as opposed to going through that whole drop and recreate stuff. That's one area where I've happened to have used it before. Transparent archiving. This kind of came out a couple of versions ago. And all this does is when I delete in a main table, it automatically moves that row into a history table, into another table. Okay, so we don't really lose our deletes. Okay, we do lose it out of our main table, but it's just automatically put into another table. Okay, most of the time DBAs wrote triggers to do this. Okay, archive process has been found to be has been faster than the trigger logic. Let me put it that way. Okay. So you create a table, you create another table like it, okay? You do an alter statement, ties those together, things automatically happen. There's some global variables having to do with this. Move to archive and get archive, okay? Both of these were set to a no when version 11 came out, and none of us could ever really understand that. You know, why would I go and tie these tables together and do a delete when you have this thing set at no, where it's not going to move it to the archive table? It doesn't make any sense. So they came out with a retrofit, this APAR in version 11, to allow us to handle that. We can handle it by vparm. And then when I select from that table, do I want my queries to only look at the main table or look at the main table and the archive table for a row? And that's where the get archive command comes into play. Okay.
Hey, Tony.
So I like that. So I got some automatic stuff happening. Yes.
I got a question from Sergi that others might want the answer to as well.
Okay.
He says he's faced some consistency issues running point-in-time queries. When running them in high update activity, the statement returns the data at the point in time requested, plus all the rows being modified at the same time we run the select statement. Is that normal?
Okay, I missed the part of that. Are you talking about global variable deletes, or are you talking back on the temporal tables?
I have to discard the reprocess result set by deleting the sys and something temporal tables, he says.
Okay. So you come in the temporal tables. Let me make sure I understand the question here. You come into the temporal tables and you do some some mass updates or something. Is that what we're talking about here?
It seems so.
And the problem that came out of that was
returns.
You know what I'm going to suggest here? I'm going to suggest that he send that to me in an email. We have a few other topics here. We're getting to the top of the hour also.
Sure, we'll have him. He says sure. He'll email you.
Yeah. Okay. That way we can spend a little bit more time talking about that. Okay.
So to answer the question, is that normal? We just say it depends.
Yeah, there we go. Grouping sets. This is another thing where we can automatically get subtotals and grand totals out in our query as we're grouping. As you see here in yellow, you know, we're getting a grand total out. We can see we get some averages out after each department, as that's kind of what we're grouping by departments and jobs. And so by doing this grouping sets like this, or we can do some cubing, I like this particular cubing kind of crazy stuff that comes out. A lot of different things come out with cubing logic. This I really like because we're getting subtotals and grand totals at the same time. And there's just so many times as us developers, as we're grouping things together, we do get subtotals and grand totals that we want to have also. Maybe it's just for reporting, and we can do that all in one query now. It's awesome. Stored procedures, okay? This is SQL PL stored procedures. We can do SQL PL stored procedures and define them as autonomous. That means what happens in the SQL PL stored procedure when they do a commit, it does not affect anything in the calling program activities that they've done. This comes in really handy on times where there's these errors that could occur with actions going on in the stored procedure, and they want to log those errors somewhere, maybe in a DB2 table. They can log it in the DB2 table, they can go back to the calling program, and that's been committed in that login, but it's up to the calling program now to do their own commits and rollbacks. So some different reasons to have that stored procedure autonomous. Logging of error information is probably the most common. Without defining is it autonomous, if a stored procedure is called and it does a rollback, it's going to roll back everything out of the calling program. If it does a commit, it's going to do everything out of the calling program. If the calling program does a commit, it's going to affect anything that the stored procedure had done. Okay, they're all one unit of work. This kind of breaks it out to be very autonomous in that unit of work. Okay, so you have to use the word autonomous in your create here. Okay, deleting of rows. I mean, this is something I always like to go over and have documented at companies, with developers. If we're doing mass deletes, out of a program, if we're doing mass updates, if we're doing mass inserts, there's a lot of ways that we can code and do that processing. Okay, here's a bunch of ways that we can, if you're going to have a program that's going to delete like tens or hundreds of thousands of rows or a quarterly basis, millions of rows, how do we do that? And I see people that have jobs that run 6 hours every Saturday night doing a bunch of modifications and stuff. Well, maybe there's some other ways that we can do that to like make it run a little bit more efficient. So here's a bunch of ways here, just at a high level, that you can delete a bunch of data out of a table. Okay. Version 12 came up with something called a piecewise delete. Okay. And we want to try to do this in a single query. But we don't want to delete 2.5 million rows at one time. It's way too many locks that's going on. Okay, so we go into a loop, and we run a delete statement where now we can put this fetch first within a delete statement, and you go through a loop. Now, what I like is when you come into some things like commits or you come into fetch first, I like to have that as a variable that comes into the programs. Okay, so what I have here is a great example of an SQL PL stored procedure program that will do exactly that. You feed it on the input parameters what table you want to delete from, what your where logic is, and what your fetch first count is. And it's going to go through and it's going to go through some looping logic. Okay, and that's what there's the top of the stored procedure. Here's I'm building my dynamic SQL, concatenating this stuff together, and I'm going through my fetch loop. Okay. So you have one stored procedure that you could go feed it out of Data Studio. You can run this and put your where logic. Doesn't have to be a program calling it. This is great for cleanup. If people, I see a lot of analysts, they run these queries every week or every month, and programs that run a long time. This is a great way to kind of go through. You can do your frequent commits, in this looping logic. Very cool stuff. Here's a way to handle it in a COBOL program. I'll show you. Okay. Explain. If I did not do an explain on a package that I had derived or built, okay, I can do an explain. I can do a bind here. I'm going off in another direction. I can do a bind to do an explain only. Okay, so it's not going to rebind it and rebuild it an optimization path possibly. It's just going to do explain only. So it's going to tell me what's going on with that. Test the access path before we replace the package. So I want to rebind this. And did the access path change? Because a lot of times people say, oh, I bet if we just rebind it, that'll fix the problem. Well, you know what? It might fix the problem. It might make the problem worse. Let's take a look and see what happens if we do rebind it. That's where this comes into play. This is awesome. Access path stability. I'm going to kind of roll through this real quick. AP compare. I think this should be a part of any package getting moved into production. We want to compare the bind and the package optimization going into production to what it was before. And if there's a change, I want to be warned. Or we can make it, I want to get an error to happen and it's not going to production because there is an optimization change. We don't want things to go into production and all of a sudden start running worse. And sometimes a new optimization path will do that. So this is an example of an AP or AP compare that came out in version 10 that I think that any package that's being rebuilt on into production should have the AP compare in there. And let's get warned or something. And here's some of the output. It doesn't tell us real specifically, but it's telling you a warning that, hey, there's some differences here. Now it's up to us to do our analysis to find the differences. Okay, so you just have to look at the old, look at the new. We have to do a little bit of hard work there, but at least we got a warning that, hey, something changed. Now what changed might have been better, is going to be better. What we want to capture is those ones that might be worse because the optimization is going to be a little bit different. Okay. JSON, just a few things about JSON, very common, getting more and more common, especially in the RESTful services area. Okay, people are storing data in JSON because it's faster transmission than like XML and other types of data back and forth from these front end clients like web apps and mobile apps and anything like over the internet. There's a lot of great functions that have to do with JSON. So I'm going to kind of roll through some of these here. You create a column in a table. You give it a variable binary definition. It gets stored as binary data, and you give it a max size. Okay. Then we have these functions to pull it out of binary format to put it in English format, or take an English format and put it into binary format, or JSON val to look for something very specific inside the JSON document. So here's an example of an insert. Definition. Here's the insert. You use the assisttools.json to bson function. Here's my JSON data right here, and it stores that as a binary object in that data table. I can just query that directly, but we're not going to see anything. It's going to come back in binary data. It just looks like a bunch of garbage coming back. Okay, so there's another example of an insert, another example of an insert. Okay, and so when I pull it back out, I want to do the bson, the binary to JSON. Take it out of the binary format, the way it's stored, and show it in the JSON format, and you can take a look at the data. Okay, and you have to update the whole document now. By the way, we used to have to update the whole document on XML. Then they came out with a modification. I can just update a portion of the XML document. I think that's probably going to come in JSON pretty soon. JSON val is a function to get a specific piece of information out of the JSON document. Here's a little example of that. I can use that in where logic. Just give me all the people that within their JSON document that says that they're a manager. Okay? It's not a specific normalized column. It's a piece of information inside the document. We can query for that kind of stuff. Okay? Some other examples here. A little bit of some of these return types that kind of go into our JSON val function. There's some other JSON functions. A lot of the programs like Python and Node.js and some of these software developer kits on these mobile apps and stuff, they have some like real good built-in functions of their own that can like string through like JSON data really nice. And the reason for that is these RESTful services. We have a RESTful service class that's only like 2 days long, and the typical comment that comes out of that was, "Wow, those are much simpler than I ever thought they were going to be." And they are. It's a RESTful service is just one SQL statement stored as a package. And now these front ends, these cloud-based, systems going over the network, web apps, mobile apps, they initiate the execution of that query that's in a package in DB2 through an HTTP call. Okay, they're not sending any SQL. They're just going there, and they're not going through. They don't have any client software on their front end. But they're not going through DB2 Connect, and they're going right in to initiate this service. And when they send data that needs to be sent to it, they send it in a JSON format. The output of those RESTful services come back in a JSON format. Okay. So here's how do they get invoked? How do we create them? There's some other different ways that we can create these services. On the mainframe, we do it in a batch job. Pretty simple. You can do it out of some of these front-end tools, like Postman is a very common front-end tool for creating these and testing these once they're developed. Okay. So the key to this is, if it's just a front end sending a query or calling a stored procedure, we have to have at the client end some drivers, or they have to go through DB2 Connect, and the front end has to send an SQL statement. Even if it's a call to a stored procedure, it's an SQL statement. When you go to RESTful services, there is no SQL coming from the front end, and it doesn't need the client drivers. It just sends an HTTP call that initiates a package on your system. They send information on what they wanted, the key values in a JSON format. You can tell by the squiggly brackets and the double quotes, and they get data back in a JSON format that I'm showing you here. Very slick. People are starting to store more and more data in JSON formats, like I showed a little bit earlier, because of all this front end and cloud-based processing going on. Okay, that completes all the topics I have for today. So thank you, Scott, for having me. Hope you learned a few things today. Here's my email. Here's my Twitter. You guys can email me for some questions. Always available for consulting, contract work, training assignments. For anybody and everybody out there, we have a great selection of courseware at Themis. The material in this particular presentation falls into place in a lot of our courses here that I have listed out, and we have a few of our newest ones in 2020. We have our RESTful service that developers especially should be interested in that one. Data analytics using SQL, the percentiles and different things we can do in analytics is becoming real popular. And we can do that without even knowing any of these analytics programming languages. We can do a lot just in the SQL language. And I have a top 25 tuning tips for developers. That is one I can tell you, anybody that codes SQL in DB2 around the world should come to that SQ 1005 class, because it will tell you the way you should code good SQL and the things you should never, ever, ever code in the programming language. Every programming language, no matter what it is, has some great efficiencies. Every programming language has some inefficiencies. If nobody tells developers what the inefficiencies are, they're going to go with what they know. In SQL, it can kill your runtime from hours to seconds sometimes, just by the way the developers coded their stuff. Yes.
100% of our audience learned something from you. That's really great.
That's great. Okay, and I am done with my presentation here. Again, thank you, everybody. I'll turn this over to Scott to wind down.
This is where we wind it down. So we asked the audience, 100% of these good-looking people learned something from you today. Appreciate that you're here. Thank you, Tony, for being our guest and for your terrific presentation. Thank you, sponsors, IBM community. Go there, join. User group days, ibm.biz/usergroupday. Replays and show news, dataviewshow.com/news. And that's a wrap. We're all done. It was a great show. Thank you very much, Tony. And
yeah, thank you, everybody. I'm sorry I went a little bit over the hour, but everybody have a great rest of the week and weekend. Thanks, Scott.
Well, you had a lot of great material. It's forgivable. Bye, y'all.